A new path to fusion power. We know there is a crisis looming: climate disruption, famine, war, economic collapse. There is one known long-term answer to these problems: fusion, the power of the sun. Fusion Energy Solutions of Hawaii has an answer. Here's its story. Science and computer modeling suggest that if we don't come up with a non-fossil fuel source of energy soon, then climate disruption, famine, war, and economic collapse become unstoppable. Some predict energy and civilization collapse within 30 years. Most are unaware that the cause of these problems is we are running out of energy. We don't have 30 years of fossil fuels left. All energy input to Earth is by sunlight. Plants capture this energy, converting low-energy greenhouse gases to free oxygen and hydrocarbons. This carbon cycle needs balance, with energy usage equaling energy input. Unbalanced excessive use, called overshoot, produces greenhouse gases and has gone on over 100 years. Oil reached $140 a barrel in 2008. The economy constricted, bringing bank failures, decreased energy use, and dropping oil prices. Our world depends on economically sound, sustainable energy. The only currently known long-term answer is fusion, a reliable primary energy source. It's clean, no greenhouse gases, or long-lived radioactive waste. Ocean water has fuel for 4 trillion years, virtually an unlimited energy source. Fusion is the most important scientific and technological project we can be doing, bringing prosperity, a clean environment, end of hunger, and an energy source that never ever runs out. This is what Fusion Energy Solutions is all about, bringing these technologies to the world. Fusion combines small atoms like hydrogen to larger atoms like helium at lower energy states per mass. Excess energy is now available for use. Small amounts of matter become huge amounts of energy, as described by Einstein in E equals mc squared. With helium energetically more stable, this reaction wants to happen. There's a fusion barrier called the Coulomb potential. Two positive charges close together want to repel, but the nuclei must touch each other. Then the nuclear strong force takes over and the nuclei fuse, making a new atom. This force is stronger than the electric repulsion. Nuclei need sufficient velocity and direction for intentional collision to fusion. The fusion barrier is only overcome with one of three forces: gravitational field, magnetic field, or electric field. The sun uses gravitational field force with gravity proportional to mass. The smallest theoretical mass for fusion is approximately 8 times the mass of the planet Jupiter. This eliminates using gravitational force on Earth. Gravitational force in the sun's core is sufficient that hydrogen ions collide randomly with sufficient numbers, maintaining fusion. The sun is a balance between gravitational forces pulling in and the expansion from high-energy fusion pushing out. A good plan was to imitate the sun. Magnetic field force, proportional to electric current, is used in a process called magnetic confinement. Superconductivity eliminates opposing electrical resistance by cooling electromagnets to about minus 450 degrees Fahrenheit. These magnetic fields form a magnetic bottle holding hot plasma. Particles are in a soup hot enough that every once in a while 2 protons head towards each other with sufficient energy that before they get repulsed, the strong nuclear force takes over, grabbing them, creating a new atom. The Lawson criterion of 1955 gives temperatures, pressures, and confinement times needed for spontaneous fusion. The magnetic bottle is supposed to hold plasma at millions of degrees, yet the magnets must remain over 450 degrees below zero or fusion stops, while power needs to cross the cold magnets to release energy. This engineering contradiction is not resolved, hinders progress, and with over $1 trillion spent, we still don't have commercial fusion power. Fusion Energy Solutions of Hawaii, with 2 others, has developed a fusion process using the last available force, an electric field. It's only proportional to voltage with no relationship to current. An electric field can exist with zero current flowing, resulting in no power consumption. This is the theoretical basis of a highly efficient fusion process we call velocity impact fusion. Ions are directed and driven to collision at fusion reactive velocities by an electric field particle accelerator. The nuclei have to touch each other, then the strong nuclear force takes over, forming a new atom. Its attractive force is stronger than the electric repulsion of the Coulomb barrier. Fusion happens when nuclei intentionally directed towards each other with sufficient velocity to touch. Positive ions are directed to a target with sufficient velocity that their collisions result in fusion. Brookhaven National Laboratory in New York was the first attempting velocity impact fusion. Heavy water ice crystals were ionized and accelerated by a DC linear particle accelerator to a titanium target. Heavy water ice crystal fuel produced inconsistent results, causing project termination. They were published in Physical Review Letters of September 1989, announcing a new pathway to fusion, which it most definitely represents. Independently, in approximately the year 2000, Lawrence Berkeley National Laboratories and Dr. Deleuze developed newer approaches to velocity impact fusion, filing U.S. patents. The Berkeley Lab patent issued in 2006 to Dr. Liang, disclosing a concentric DC particle accelerator. Externally ionized ions are accelerated by a DC to a central target. It works well, proving velocity impact fusion. DC drive draws high currents, resulting in far less power output than it takes for operation. This lack of gain is not a concern in its very successful application to neutron imaging. A U.S. patent issued to Dr. Deleuze in 2012 disclosing a concentric AC particle accelerator. The Deleuze reactor will have an extremely high power gain, needing but a very small fraction of its power output for operation. AC drive results only in capacitive reactance using no real power. Our fusion reactor includes a ground plane, insulated reactor envelope, central target, and power supply. The rotating vector in the power supply represents the direction and intensity of applied electric potential. Its electrical rotation results in a progressively increasing and decreasing electric field alternately changing direction within the reactor. This is shown by the size and pointing of the yellow arrows. Starting with the AC vector at 0 degrees, we progress stepwise through an operational sequence. As the AC vector rotates from 0, the initial small electric field polarizes the gas. Polar hydrogen atoms align along radial axis extending outward from the central target with electronegative poles pointing towards the ground plane. With progressively increasing electric field strength, the proton-electron bond lengthens till it breaks, causing ionization. As the proton has 1,800 times the electron's mass, electrons quickly accelerate, reaching the reactor envelope. On capture, they define a conductor which forms the inner two plates of a capacitive voltage divider. Applied voltage concentrates across the inner smaller capacitor. With 200,000 volts applied, over 160,000 volts focus centrally, forming the acceleration potential. Within the time domain, conditions within our reactor are now exactly the same as within the Lawrence Berkeley reactor. Enclosed positive ions are bound peripherally with a positive charge and centrally with a negative charge. Ions accelerate to the target with fusion reactive velocities in both cases. We propose deuterium-deuterium fusion producing helium-3 waste and 2.45 million electron-volt neutrons. A neutron flux is shown as a purple flash surrounding the fusion reaction. Neutrons radiate outward from the reactor core to surrounding medium, transferring nuclear energy for heat to do work. Water surrounding the core is the moderator, where created nuclear energy transforms to heat, producing the steam operating the power plant. Electric power is produced with no carbon dioxide emissions. Unlike dangerous fission nuclear power plants, fusion power plants produce no long-lived radioactive wastes. Fusion will produce power as long as we need it using fuel from ocean water. The quantum leap fusion power brings will change our world over the next 100 years in ways unimagined, seemingly impossible changes. Thank you and mahalo.